breaking news. There's a man and his spouse trying to arrange nuptials, and they're arguing over it. What could possibly happen? And they're perfect logicians. Yep. John's on the case. What do you have to say about this problem, John?
To start, we will start looking for any dominant strategies for either you or the spouse, aka when picking one case will always be the best case for you or your spouse. Unfortunately, this doesn't exist in this case because the best picks, depending on what you or the other picks, are like this, with the green being your best picks. Oh well, now if you notice, you should never pick 4 to 8 p.m. because there are no green spots on it, so it is never in your best case. It's never your best case to pick that. So it's never rational for you to pick that. Well, because neither you or your wife will pull irrational pranks like pieing each other, we can just eliminate those choices because they are called dominated strategies. So let's move on and just keep iterating that over and over. If it's not clear enough, we're just removing the rolls without any green spots on them for both you and your spouse. And we can simplify the problem to this. Alright, once you have this, of your 2 times that you can pick, right? If you pick 12 to 4 p.m., you get the minimum of your 2 best cases. So you get 49 instead of 64. And you get the minimum of your 2 worst cases, so you get 85 instead of 88. So you should pick 12 to 4 p.m. and you guarantee that if they pick classical, you guarantee you pay at most $85.
Our next case, another breaking news story. A man is trying to prank McDonald's. What do you, John? I think, yeah, John's on the case. What's up with this prank, John? Tell us about it.
Chicken nuggets and hamburgers.
Let's call the optimal probability of you picking a chicken nuggets P of C of n. The restaurant wants to expect the utility of C of n and hamburger to be the same for both chicken nuggets and hamburgers because otherwise you being a hyper-rational person will just adjust your choice probabilities to make it so your expected utility is more and theirs is less. Because your best results is their worst results, you guys are diametrically opposed, which is why this happens. Thus, let's call the expected utility of chicken nuggets, meaning they are picking chicken nuggets, EU sub Cn. So, if they pick chicken nuggets, then their expected value is the probability that you pick chicken nuggets or hamburgers multiplied by their respective values. As such, you have EU sub Cn is 11 times the probability you pick a chicken nuggets, plus 55 times the probability that you don't pick it, that you pick hamburgers. So it's 1 minus PC of n. Now, for hamburgers, you just do the same thing. So you can just set them equal to find the probability you should use to pick chicken nuggets, and you get that it's 48/87. And the probability you pick hamburgers is just 1 minus that, which is 39/87. So those are your optimal mixed strategies, is picking them with a random chance, but with probability 48/87 for chicken nuggets and 39/87 for hamburgers.
Oh, this is an emergency situation. We have 2 people flipping coins, battling it out. I think, John, can you cover this one? What's going on over there, John? This those raining cats and dogs. What's going on, John?
Alright, so let's make a table first because visuals are really nice. Okay, so for a fair coin, your expected value is the probability of each situation multiplied by its value for you. Since you don't care about your opponent's expected value for this problem, we will ignore it and simplify the table to this. The probability of each situation happening with fair coins is 1/4 because it's fair. So you can just add up all your expected values and multiply that by 1/4 to get your total expected value is losing 1/4 of a dollar. But the probability of the weighted coin is different for heads and tails. So they're listed out here, right? And you can see that the probability for heads for you is 3/8, while the probability of tails for you is 1/8. So if you take the probability of heads for you and add up the expected value for heads for you, and the probability for tails for you and add up the expected value for tails for you, you get your total expected value is 1/8. Meaning that in these 2 scenarios, if you just take your expected values for both cases and multiply them by the number of iterations, you can just get the total expected value out of both scenarios. So for scenario 1, you lose $25/4, and for scenario 2, you gain $11/4.
Our final story tonight. It appears that John has broken all of the breaking news. Great job, John. We'll see you tomorrow for more breaking news. Good night.